Okay, something kind of different today. I'm doing the rare algebra problem on this channel. I got this idea from a video by Sybermath. What I ended up with here is quite a bit different looking, but I'll provide a link to the video he did and you'll probably see why I'm doing this, but it's not the same thing. It's not the same problem that he had. Now, the thing that kind of got my attention on this one is the similarity to the change of base formula for a logarithm. Like if we have log base a of b, the change of base formula allows us to write this as, say, ln b over ln a. And actually, this here doesn't have to be natural log. This could be any base, and you could do the same thing. So our problem is basically in the form of the right side of the equation, so we could go this way. But now this would be a lot simpler if, let's say, instead of, we've got radicals here. If we just had, say, something like this, well, then with the change of base formula, doing this in reverse, we could write this as log base 3 of 27, and this is just 3. But the trouble we have here is if we do the same thing on our problem, let's see what we have. So with what we have here, you may notice this is kind of an ugly thing. What I did over here to solve this so fast, right, is just knowing, like I know what power I need to raise 3 to get to 27. But it does seem a lot harder. What power do I need to raise 51 minus 10 to the square root of 26 to get this? Now at this point in the problem, I got another idea. There was something in the comments that I've seen a few times where it says something like, isn't this a contrived problem? Isn't this like, what's the application to this? And I think a lot of the times there's no application and it is kind of a contrived problem. And for something like this, for this to work, it really needs to be a contrived problem because like, let's say, pretend like the solution of this is gonna be 37.4 or something. Well, if the answer was 37.4, I'm not sure how I'm going to do it without a calculator. I mean, like Wolfram Alpha might be able to get you this answer, but I don't know how I'm going to like calculate that root by hand in a reasonable amount of time, right? So I think when doing math problems in a contest or in a test or in class or whatever, you kind of have to assume there's a trick or a nice way to do it. Otherwise, we could be here working on this all day. So what I want to do for an assumption is I want to assume that this thing right here is something nice, and particularly it's a lot like these nested radical problems. If this problem, we could actually do this. If we got this problem, we had to simplify this. Well, again, the key is that hopefully this thing here is something nice, and what we really want it to be is a perfect square. So we'll just do that same thing on this, getting this into the form of a perfect square, and then we'll see if we can get simplification. So for my process on this thing, the way I would do it is I want a 2 in front here because if this thing is in the form of something like square root of a minus square root of b, this is going to work basically the same way with a plus or a minus, so don't let that bother you too much. But if you square out this thing, what you're going to get is a plus this piece is going to be b, and then the middle terms multiplied out is 2 square root a b. So for this thing, for the 10, I can break that up as 2 times 5 in order to get our 2. And then for the 5, I can square it and multiply it in. So what I'm saying is we can write this as 51 minus 2, squaring the 5. Let's leave it unsimplified. When we square 5 and bring it inside the radical, we have a 25, and we still have this 26 here. But then you'll notice 25 plus 26 gives us our 51. So really what happened is we just found our a and b values here, and we have something in this form. Then from here, what I'll do is we'll put this into this form. So we'll call our a, we want it to be positive inside the radical, that's why I'm going to take the larger number. So we'll do it as square root 26 minus square root of 25, all squared. But inside the radical, this is going to be the same thing as square root of 26 minus square root of 25. So now coming back to our original problem over here and trying to solve this thing, let's try to match to this format. So like for 5 here, I can write that as square root of 25. And then we can have it, I should probably change the order to get it like this, but whatever, we'll leave it like this right now. For this piece right here, I can write it as this here squared. So I can write this as natural log square root 26 minus square root 25 all squared. But then by exponent properties, I can bring this out front of the logarithm. So now when I rewrite it, let me reorder it now. So I'm gonna, first the numerator will write as square root of 26 plus square root 25. And then the denominator, I'm just going to write it with the 2 out front like this. And now at this point, we're almost done, but the only problem is we don't have the same sign. If this was a plus here or this was a minus, we would just cancel it and have 1/2. but it's not quite set up that way yet. What we can do on this is one more step. We have this thing, if I have something like 1 over n squared plus 1 plus n, notice the denominator is in the same format as this. If this here, you could write this as square root n squared, where n's 5. So if n's 5, it's going to be just this exactly. But then to simplify this, what we can do is multiply in the conjugate. So I can multiply by n squared plus 1, square root n squared plus 1 minus n, and do it numerator and denominator. So we're multiplying by 1. If you multiply it out, then we just get this thing back in the numerator. But then simplifying the denominator, these things multiplied together squared, you get n squared plus 1. These terms multiplied together minus n squared. The middle terms cancel out. The n squareds cancel out, so now you just have a 1 in the denominator. And so just cleaning this up, we have 1 square root n squared plus 1 plus n is equal to just n squared plus 1 minus n. But then, of course, I could just take the reciprocal on both sides of this, and so we could have the same kind of thing. We could have 1 over n squared plus 1 minus n equals this thing. Now with this, we can use either one of these because we've got both forms here, but let's deal with this one. So if I have this right here, I can take square root 26 minus square root 25 and write it like this: 1 over square root 26 plus square root of 25. I mean, of course, you could write it as just plus 5, but I want to be consistent with the format we're using here. But for logarithms, I want to write this as an exponent. So instead of writing it like this, let's write it as square root 26 plus square root 25 to the minus 1. And then let's just take that and we'll throw it back in right here. But now here I can just use log properties again, bring the exponent out front. So let's get rid of this and just put it on the 2. But then, of course, we just cancel this with this here, left with a 1 in the numerator. So for my final solution of this, we just get minus 1/2. Okay, so like I was saying earlier, it kind of needed to be a clean solution. Like it had to be like 2 1/2 or the minus, minus 2. Even for an answer like 1/3 or cubed, it starts getting pretty complicated. I have a quiz on my website with the nested cube roots or something, and it gets a lot more complicated than the square root case. And I think anything beyond the cube root case is basically impossible unless there's some really nice like simplification, like you just have all 1s and 2s or something really simple. Okay, that's it for today. Thanks everyone for watching. Have a good day.